Black holes have always intrigued me. No one knows what lies within the inner reaches of a black hole, and to be honest, we probably won't find out anytime soon. For those of you who don't particularly know too much about black holes, aside from them basically being objects in our universe which suck up matter, so to speak, whether that may be stars, planets, or any other celestial body, I'll be going into depth with them here. These mysterious points in space are much more abundant than you'd think. From what we know now, there are roughly 100 million black holes in the Milky Way galaxy alone. Crazy, right? There are mainly three types of black holes. Stellar black holes, or most commonly referred to as stellar mass black holes, which are most likely what people think of when someone mentions a black hole. These types of black holes form when a massive star at least 25 times the mass of our Sun collapses, resulting in a super or hypernova, and usually ending up having a mass of 5 to several tens of solar masses. So normally up to, like 30 or something. Anything below 5 most of the time will result in a neutron star or even a white dwarf. More on that in a different video though. Then we have supermassive black holes, which are what we find at the center of most galaxies. These types of black holes have masses ranging from hundreds of thousands to several billions of times the mass of our own Sun. No one really knows how they got so big, but a common speculation is that these were formed at the very early stages of our universe's creation. Sagittarius A, or better known as what we think is the supermassive black hole at the center of our own galaxy. Technically, it is just an astronomical radio source that we found, but we just inferred that it's our black hole considering the sheer magnitude of it. Sagittarius A is around 4.6 million times the mass of our Sun. This bad boy is a whopping 27.34 million miles across. To put that into perspective, the United States is roughly 3,000 miles from coast to coast, depending on where you start and end from. You could fit a little more than 9,113 United States across the surface of the black hole alone, or 3,453 Earths stretched out. That, for some reason, may not seem like a lot to some of you, but think about how big the Sun is, and then multiply that by 31. That's how big this thing is on its surface alone. Not to mention its mass is several millions of times more than our Sun. Crazy to think about, in my opinion. Then we have intermediate-sized black holes, which we really have only been able to speculate until recently. For some reason, we have been largely unable to find intermediate black holes, which, as the name implies, are bigger than your average stellar mass, but also smaller than the supermassive one. For reference, intermediate black holes have a mass of about 10 to the 2 to 10 to the 5 solar masses, or rather 100 to 100,000. Within the past year, scientists in Japan have found that an intermediate black hole is just about 20 light years away from Sagittarius A. It is speculated that this particular black hole is around 30,000 solar masses. It is destined to meet its end when it collides into the supermassive black hole in the center of our galaxy in due time, though. This finding may confirm our theories of how supermassive black holes form. Now let's talk about the event horizon. The event horizon of a black hole usually is what is described as the threshold around the black hole where the escape velocity is faster than the speed of light. So this means that pretty much nothing in the universe can escape its grasp, aside from a few unproven quantum theories, including how virtual particle pair may be able to appear right at the edge of the event horizon, and one side can escape and form into a real particle somehow while the other dies in the black hole. But then again, this is completely unproven. But that being said, once you cross the event horizon, there's nowhere to go but straight towards the singularity. Every black hole has a singularity, which essentially is a one-dimensional point in space which is infinitely small and has an infinite density and gravity. This in turn warps space-time, greatly causing a dip, so to speak. Imagine this dip as if a truck were to be placed on an elastic net spanning the Grand Canyon. The net in this demonstration is space-time. The net, or space-time, would dip down because of the truck's mass, and you could think of the truck as the black hole. Then imagine the same scenario, but with a person on the net instead. You could think of the person as the Earth. This would bend space-time far less because of how much less mass it carries. This picture here is a good indicator of what I'm talking about. Thankfully, we don't live anywhere near a black hole that would affect us, but maybe it would be a good thing, or if you think about it, maybe it would finally click for, the political leaders and what's important on our race and our civilization as a whole. Not money, not power, not land. We would all have a singular focus to advance our civilization and reach out into the vast openness of space. Our Earth won't be here forever, and a cataclysmic event could happen at any time. If we pull together our resources, time, and energy, I'm very confident that we would be a much more advanced civilization than we are now. But alas, we're more worried about our borders, who has the biggest army, which corporations are doing well, or even if Sally in sociology will be the one. But truly, I am thankful for being alive at the time that we are and getting to live here on this lush blue-green planet we can call home.